question. Let's try a science question. Hopefully it'll stay with me. It's being a little slow today. Alright. Let's see what we got. Alright, so you are not putting your notebook up. I'm going to read it out loud. Then you're going to try and move your notebook. But don't be a distraction. It's fine. It was very cold last night at Carrie's house. Ice formed on the side of her roof. When the sun came out in the morning, the ice began to melt into water. How did the ice change as it melted? How did it change as it melted? So we have A, the ice changed from a solid to a liquid. B, the ice did not change. C, the ice changed from a liquid to a gas. Or D, the ice changed from a solid to a gas. You're not putting your notebook up. You're just rearranging it to make sure that you're ready when it's time to scan. Alright, let's go ahead and scan. Hopefully it'll go a little quicker. There we go. Once you see it, check your name. You can put it down so I can get people behind you. Alright, we got everybody? What are we thinking? What are we thinking? What's happening to that ice as it melted? That was one of our change words. That was one of our change words. Bradley, what's happening?
The ice changed from solid to liquid.
Let's see what you guys pick. Yes. The ice changed from a solid to a liquid. Very good. Very good. Alright, let's try. Ooh, let's try this one. Sarah bought a can of soda at the pool and left the soda in the sun. I was supposed to say while she swam this cooler. When Sarah came back, the soda was warm. What raised the temperature of her soda? Was it the sound of the people's voices? Was it the water that splashed from the pool? Was it the bees that were flying around the soda can? Or was it the heat energy from the sun? Think about what would have changed or raised the temperature of her soda. She left it out at the pool. Went swimming, came back, and it was warm. How did that happen? Alright, let's go ahead and scan. Again, when your name gets a check, you can put it away. That way I can get everybody's choices. Alright, I got everybody. What are we thinking?
Eva didn't get it.
Oh, sorry, Eva. Well, let me see if I got it again. Alright, Eva, you're good. You're good. What are we thinking? What is causing the temperature to change? What is causing the temperature of that soda to change? Peter, what are you thinking?
D.
You think D?
Yeah.
Heat from the sun?
Yeah.
A lot of you picked that. A lot of you were right. A lot of you were right. Yes, the heat from the sun is what was moving that temperature in the soda up. Alright, let's try another one. Good one. Pedro chopped lettuce, tomatoes, cucumbers, and carrots. He placed the chopped vegetables in a bowl to make a salad. Pedro's salad is an example of a mixture, an evaporation dish, a solution, a filter. Remember we did the sieve where we had to pour the water through my evaporation dish, which is what we got sitting outside right now, solution, or filter? Alright, let's scan them. I'm not gonna click the right thing.
Will be on.
Yeah.
Where?
No, not you, literally.
Oh.
Your notebook.
Oh. There you go. And our books are they're not blue though. Yeah, they're not blue.
Alright. What do we think it is? So I didn't pick a correct answer on this one. But you guys are a little bit split. I'm glad nobody picked an evaporation dish and nobody picked a filter. Is it a mixture or is it a solution? I need you to raise your hand and tell me why. Is it a mixture or a solution? We're a little bit halvesies. Which one is it and why? Lene?
It's a mixture because he's mixing tomatoes, cucumbers, carrots into a dish.
Okay, that's part of it. That's not completely why it's a mixture. That's only half of it. Why else is that a mixture? Samantha?
It's a mixture because you can take it apart and put it into fruit.
You can easily unmix it.
But Miss Miller, I thought it was silly because the carrot.
It wants to know the salad, Pedro's salad is an example. That was a good, that kind of tricked you a little bit. Pedro's salad, so the idea that all these vegetables are in a bowl, that salad is a mixture. I know what you were thinking, so Ada was thinking, well, you can't uncut a vegetable. Definitely true. But I want to know all these different parts in the salad, is that a mixture or a solution? And it's a mixture because you can easily take those parts back out again. Alright, let's try another one. Alright, Kim wants to see what happens to chocolate chips if they are placed in a bowl and heated in the microwave. Which is likely the most accurate prediction Kim can make about what is going to happen to those chips? Is it going to be A, heat will have no effect on the chocolate chips?
No.
B, no. B, when melted, the chocolate will weigh less. C, when melted, the chocolate will weigh more. D, when melted, the chocolate will take the shape of a bowl. This is tricky. You need to think back to what we learned from the melting race. You need to think back what we learned about solids, liquids, and gases. Lee, do you have a question?
No, but can I get a paper towel?
Yeah. This is a tricky one. Tricky one. Is that what we learned about when we did the melting race? You have a question?
How many chocolate chips does she have?
I don't think it matters.
Okay.
A bowl full.
Oh. Can I get a bag?
Alright, ready to give this one a shot? This is a hard one. This is a hard one. Alright, go ahead and throw them up. Once your name gets a check, we'll put it up. Good? Got everybody that's here? Lauren's fine. It's fine. Alright, what are we thinking? Let's first talk, what's going to happen to those chocolate chips in the microwave? What's going to happen to those chocolate chips in the microwave? What's going to happen, Lene?
They're gonna melt?
They're going to melt. So is heat going to have no effect on the chips?
No.
No. Definitely not that. We know it's not that. Heat's definitely going to do something. They are going to melt. Melt into what?
Chocolate.
Melt into what? Lenny, what are they melting into? They're melting into, give me a state first. A liquid. And we know that liquids take the shape of whatever they're sitting in. If I have a tall, skinny water bottle, that liquid is a tall, skinny water bottle. If I have a big old bowl, that liquid is the bowl. Is it going to weigh more or less? We weighed our ice cube after the melting race.
Yes.
Did it weigh more or less? If you have something to say, please raise your hand. Like everybody else. Aiden, is it going to weigh more or less?
It's going to weigh more because the chocolate is heavier than this little chocolate chip.
Did our ice cube weigh more when it was water?
It weighed the same.
So when I melt a chocolate chip, is it going to weigh more? Or do you think it's going to weigh the same? It's going to weigh the same. Some of you got tricked. This one, it's not going to change the weight at all. Think back to the melting race. We weighed that ice cube, and then we melted it. That weight of that water, whether it was solid or liquid, did not change. So if I'm melting a solid chocolate chip back down to a liquid, it is not going to change weight. It's still chocolate chips. One of them just looks like chocolate chips, and the other one looks like chocolate lava. Okay? So the answer to this one is D. It's D. Brent, you did not pick that answer.
Yes, I did.
No, you didn't. You picked A.
No.
Yes, I have it on my screen. So be more careful with how you are picking instead of just throwing it up there. All right, let's try this one. Got two more. Oops, go ahead and erase that. The ice cube, I was supposed to have a picture, but I don't have a picture. The ice cube is melting or changing from a solid to a gas, liquid to a gas, solid to a liquid, liquid to a solid. Now it's changing. Well, those change words, melting. Ice cube is melting. Changing from a what to a what? Melting is changing a what to a what? Alright, let's go ahead and stand. Make sure you have it the correct way. Make sure you have it the correct way. Normally I cannot do this, it's sideways. I can't read it if your fingers are in the middle of it. Alright, melting is changing a what to a what? Raise your hand to tell me. Melting, changing a what to a what? Right?
A solid to a liquid.
Solid to a liquid. Is it a solid to a liquid? Yes. Solid to a liquid. Ice cube is a solid. If it melts, it's going to turn into water. A water is a liquid. Alright, last one. Last one. The solid we call steel is a hard metal often used to construct buildings. What can happen when steel gets very hot? Think about what it is. A, it will always stay the same. B, it can turn into a liquid. C, it can get smaller. D, it can disappear. The solid we call steel, the hard metal, often used to construct buildings. It's used when you're building a building. What can happen when the steel gets very hot? what change could happen. Alright, let's go ahead and scan. Please stop talking, thanks. Hold it the right way. You don't want to get the wrong answer just because you are holding your thing wrong.
Oh, yeah.
Try and turn it towards you first. There we go. Mitchell, I didn't get yours. Oh, Mitchell, here we go. Alright, Mitchell, yeah. It'll take a little bit to stop it. Alright. What's going to happen? It's a solid. That solid is heating up, getting very, very hot. What change is going to happen? What change is going to happen? All of you answer. Why do I have nobody raising their hand? What change is going to happen? Matthew, what change is going to happen?
It can turn into a liquid.
So we got, it'll turn into a liquid, or will it always stay the same? A lot of us thought, it can be used to make buildings, so it must just stay the same. But it's a solid, and all solids can melt. So if it gets hot enough, even steel, it can turn into a liquid. It can. Alright, and I have a real story about that. So my dad lives in Dallas. Dallas is in Texas. Texas gets ridiculously hot. Like, you think it gets hot here, it gets like 115 degrees. And that's normal. It gets so hot. There are these giant skyscrapers in the city of Dallas, downtown Dallas. Can you picture that? These giant buildings? They're called skyscrapers. Yep. They have glass windows. And for my Boy Scouts, you know that you can use glass and the power of the sun to get something very, very hot and eventually start a fire. You're harnessing the power of light, angling it through glass, a powerful beam of light that gets so hot it can start a fire. So you have these giant, tall skyscraper buildings. There's an art garden, beautiful, in the middle of downtown Dallas. We walked past it. Got a lot of paintings in the building. Outside, beautiful fountains, beautiful landscaping, beautiful sculptures. Those sculptures are made out of steel. They're super rare, been there for probably hundreds of years. Beautiful art. These skyscrapers, because they're so tall and because they have so many windows, are acting like a giant piece of glass over top of these sculptures. So when it gets 115 degrees and the sun is beating down, it's hitting the glass, which is then turning it into a really powerful beam of sunlight and shining right on the sculpture garden. So the sculpture garden is getting damaged and starting to disfigure because the steel is getting very, very hot. So where it's connected, it's starting to break down, it's starting to melt. Isn't that great?
The pictures are going to get messed up.
They are going to get mixed up. So there's a big argument right now of what to do. Because we have these giant buildings where all these people work, and then we have this art that's been here for forever. What do we do? But I just want to tell you that this is a true thing. It can happen. It doesn't happen very often, but it can happen.
It's once.
I think